Objective 11 and 12, be able to write the noble gas configuration for any element as either a neutral atom or ion. And then 12, be able to predict the ratios, write the formulas, and correctly name the ionic compounds. So I'm just going to scroll down so we can see the examples I have here. So the first one, if we're looking at iron and oxygen, what would the configuration for neutral iron look like? Well, we just used this one. We said it's number 26 in period 4. So it's argon is its noble gas from period 3. And then the 4s2 fills up. And then the 3D has 6 in it. Whereas if we look at neutral oxygen or oxygen atoms, oxygen's in the second row, so its configuration is going to be helium. And it's going to be 2s2 and 2p4. So when you look at either their configuration or where they're at on the periodic table, what should iron 2 do to get stable? Well, that 2 is a hint. Why is there a 2 in the name? Because that's the charge it's going to pick up. Yeah, that's how many electrons it's going to lose. Iron's got 2 valence electrons, but just a little bit ago we looked inside. It could lose 2 or 3. So this time it's going to lose 2. So yeah, we just did this example. You'll have, that's what it looks like as an atom. So if it loses 2, boom, those 2 are going to come off, and this time we'll do it right. Now you have a 2+ charge on it. So there's your iron 2 ion. Oxygen ion, what's oxygen going to do to get stable? Yeah, it needs to gain 2. So it's got 2s2, 2p4, so when it gains 2, they go into, fill up this p, 2s2, 2p6, so now it's got 8, and that gives it a 2- charge. So then the ratio for iron 2 and oxygen, this is where I draw, I like to draw the little boxes, and you don't have to. All I'm going to look for is the formula. So if I know Fe loses 2, I'm going to draw a box to show that's 1 iron ion, and I know oxygen needs 2. I can look at that and see that the ratio is I just need 1 of these for 1 of these. So my ratio is 1:1. And the formula then is just FeO. And the name for this one is iron, and I have to include the 2. And then oxygen is changed to oxide to let me know it's an ion now. So we just covered 2 of the 3 rules for formula writing. Rule 1 is the number of electrons lost has to equal the number of electrons gained. Rule 2 is if there's a Roman numeral or a transition element, a transition metal, you need the Roman numeral to tell you how many electrons are going to be lost. Rule 3 has to do with parentheses and the polyatomic ions, so that's the second example we'll look at here. So let me just clear my ink there. So calcium and phosphate, neutral calcium is over in period 4, so its noble gas is argon, and then it's just 4s2. So what's calcium going to do to get stable? Lose those 2, so it's just going to be argon. Oops. The 2+ charge, it's going to lose those 4s2 electrons. And then phosphate ion, you're not going to be asked to draw the noble gas configuration because it's a group. There's not a configuration because phosphate is PO4. It's a big group. So that's the group is PO4, and it says the charge on it is a 3-. So again, if I follow my same procedure I just did, sketch my little box here. Calcium has 2 it needs to get rid of, but this big phosphate group, PO4, needs 3 for 1. So 1 of each isn't going to work. So for sure I need 1 more calcium, but now that messes it up too. So I'm going to need another phosphate. And another calcium. So rule number 1, electrons lost, I lost 6. Electrons gained, I gained 6. Electrons lost and gained are equal to each other. And so now when I write the ratio for calcium to phosphate is I use 3 calcium and 2 phosphate. So I'll give myself a new line here. So the ratio is 3 to 2. The formula is going to be Ca with the 3. The subscript tells me 3 calcium. And now the phosphate, I've got PO4, but because that's a group and I have more than 1, just like in math, if you want to show a group of more than 1, you put parentheses around the whole group. I'm having a little trouble here. Put parentheses. There you go. Parentheses around the whole group. And then use a subscript to tell me how many. So Ca3, parentheses PO4, parentheses 2. And the name of this one, these are the easiest to name because you don't change anything. You just take both their names right off the chart you have. Calcium from the periodic table, and on the back the chart says PO4 is phosphate.